All right, let's take a look at the practice test. For the instructions, we're asked to show there is a 0 between the two numbers given. All right, for problem 1, we're given f of x equals x to the 5th power minus 3x to the 4th power plus 4x cubed minus 12x squared minus 12x plus 36. We want to show that there's a 0 between -1 and 2. So how do we do this? We're going to use the Intermediate Value Theorem. Let me just show you this with a graph real quick. So we're going to graph this guy right here, and I'll leave a link for you on Desmos so you can follow along. But essentially, you're going to find out in a moment that f of -1 is positive 28. Let me just write that here. So f of -1 is positive 28, and I'll do that with synthetic division. And then here we have f of 2. So f of 2 is -20. So how do I know that based on this information, there's a 0 between -1 and positive 2? Your 0 is actually going to be right there. You can see it on the graph. Well, the reason we know that is because this is a continuous curve for your polynomial function. So if this guy right here is positive in terms of the y value, it's positive 28, that means we're above the x-axis. This guy down here is negative in terms of the y value. That means we're below the x-axis. So again, if this is continuous, we can only get from above the x-axis to below the x-axis by passing through the x-axis itself. It's very, very simple. So this right here is where you're going to hit the x-axis. So that's going to be your root or your 0. So when you have one of these guys being positive and the other one being negative, you can conclude that there's going to be a real 0 between those two numbers. So let me come back up and we'll just do this really quickly. So we're going to use synthetic division. Again, if you want to plug in, that's fine as well. So I'm just going to go -1 out here, and then we'll put a 1, a -3, a 4, a -12, a -12 again, and then a 36. So hopefully you know how to do synthetic division at this point. So we're going to drop down this 1. -1 times 1 is -1. Then -3 plus -1 is -4. -1 times -4 is positive 4. 4 plus 4 is 8. -1 times 8 is -8. -12 plus -8 is -20. -1 times -20 is positive 20. And then -12 plus 20, that's going to be positive 8. And then -1 times 8, that's going to be -8. And so 36 plus -8, that's going to be 28. And again, we saw that f of -1 was equal to 28 on the graph. Let me just write that f of -1 is equal to, so this is positive 28. Okay, let me get rid of this. We're going to keep those coefficients in there. We're going to change the value of k to 2 now. All right, let me drop this down. So 2 times 1 is going to be 2. -3 plus 2, that's going to be -1. 2 times -1 is -2. 4 plus -2 is 2. 2 times 2 is going to be 4. -12 plus 4 is going to be -8. 2 times -8 is going to be -16. So -12 plus -16, that's going to be -28. And then if we do 2 times -28, that's going to be -56. Let me fix this 8 here. Then if you do 36 plus -56, you get -20. And again, we saw from the graph that our f of 2 was equal to -20. So we can get rid of this. We don't need this anymore. Again, you don't have to go to a graph each time. That's unnecessary. If you get this type of problem, just figure out what f of -1 is, and that's 28 in this case, that's positive. Then figure out what f of 2 is. In this case, that's -20. Again, it's negative. So if one is positive and one is negative, then you can conclude that you're going to have a real 0 between those two values. So between -1 and 2. All right, for problem 2, we have f of x equals x cubed plus 7x squared plus 13x plus 3. So again, I'll just show you this with a graph real quick. I'll leave a link for you on Desmos. This is -4 comma -1. So in other words, if you said f of -4, you're going to say that's equal to -1. And this is 0 comma 3. So f of 0, that's going to be 3. So this is negative in terms of the y value, and this is positive. Again, because this is a continuous curve, this guy right here, if it's going to go from below the x-axis to above the x-axis, it has to pass through the x-axis itself. Now, in this particular case, you're going to notice that you're going to hit a 0 right there, and right there. That is okay. We're just saying that there's at least one real 0 between an x value of -4 and an x value of 0. It doesn't matter that there's more than one. That's okay. So we're going to go back up, and we're just going to show this real quick. So if you want f of -4, you can just do this with synthetic division. Again, you can plug in also if you want. So this is a 1, a 7, you have a 13, and then a 3. Let's drop this down. So -4 times 1 is -4. So 7 plus -4 is going to be 3. -4 times 3 is -12. 13 plus -12 is 1. -4 times 1 is going to be -4. 3 plus -4 is -1. So we can see that, again, f of -4 is going to be equal to -1. Now, we can get rid of this. We don't need it anymore because for 0, that's one that I would not use synthetic division for because you could just plug in. So we'll just say that f of 0 is just going to be equal to what? Well, anywhere where I plug in a 0 for x, it's just going to go away basically. You'd have 0 plus 0 plus 0. You just get rid of that. So then you have the plus 3, so it's just going to be 3. So if we look at this f of -4 is -1, so it's a negative, and then f of 0 is 3, so it's a positive. So again, because this is negative and this is positive, we know that we have a 0 between those two values. Again, even though there's more than one 0, that's okay. We're just using this to say we know we have at least one real 0 between the two values of -4 and 0. All right, so the instructions are going to change. We want to determine if k is an upper bound, a lower bound, or the test is inconclusive. All right, so coming down to problem 3, we have f of x equals 2x to the 4th power plus 10x cubed plus 14x squared plus 6x. We're given a k value that's 2. So if the k value you get is positive, you're going to check for an upper bound. You're not going to check for a lower bound. So with an upper bound, what you're going to do is set up your synthetic division, and you're going to look at the bottom row. So that's where you get your quotient, your remainder. And if everything there is non-negative, so meaning it's positive or 0, then you do have an upper bound. So you will not have a 0 that's greater than your k. So let's put 2 right there just to set up the synthetic division. So we're going to take a 2 and then a 10, a 14, a 6. Now you're missing your constant, so you want to put in a 0 there. You want that as a placeholder. So let's go ahead and drop this guy down right there and go 2 times 2, that's 4. 10 plus 4 is 14. 2 times 14 is 28. 14 plus 28, that is 42. 2 times 42 is 84. And then 6 plus 84 is 90. 2 times 90 is 180. 0 plus 180 is 180. Now, I don't care about any of this. I just want to look to see, is everything non-negative? So positive, 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 and positive. So we're good to go. So we can say that k, which here is 2, is an upper bound. So there will not be a real 0 that's greater than 2. So let me put that this is an upper bound. All right, for problem 4, we have f of x equals x to the 5th power minus x cubed minus 2x squared plus 5x minus 3. We're given a k value here that's equal to -5. So if this is negative, you want to check for a lower bound. Let me go ahead and set this up. So I'm going to put a -5 here. And then for the synthetic division, you have a 1. You're missing x to the 4th power, so you put in a 0 for that. Then you have a -1, a -2. You have a 5, and then a -3. Okay, so let me go ahead and redo that. Let me make it a little bit better there. I'm going to drop down the 1. And then -5 times 1 is -5. 0 plus -5 is -5. -5 times -5 is 25. -1 plus 25 is 24. So -5 times 24, that's going to be -120. -2 plus -120, that's going to be -122. -5 times -122, that's going to be 610. 5 plus 610 is 615. So then -5 times 615 is going to be -3075. So if you do -3 plus -3075, you're going to get -3078. So this is going to be a lower bound. And the way you know that is you're looking for alternating signs. So in other words, you're starting with a positive, then you go negative, positive, negative, positive, negative. Now, if you get something that's 0, you can use it as either. Whatever you need to make that pattern work. So in other words, let's say this was a 0 right here for whatever reason. Well, I could treat that 0 as being negative and I'd be okay. So if you get a 0, it can be treated as a positive or negative. Just use it as you need. But basically in this case, you're looking for alternating signs. So positive, negative, positive, negative, positive, negative. And we have that here. So we can say that k, which is -5, is a lower bound. So there won't be a real 0 that's less than -5. So let's put that this is a lower bound. All right, let's take a look at problem 5. So here we have f of x equals 4x to the 5th power minus 16x to the 4th power minus 8x cubed plus 16x squared plus 4x. The k value here is equal to -1. So this example here is going to help clear some things up. So a lot of students get confused because in some cases, just like this one, you're going to see that you actually have a lower bound, but when you do the test, it's going to fail. So I want to explain what's going on. Let me come down here and let me just first show you this with a graph. So this is the graph of our function, and I'll leave a link for you on Desmos. It's a little bit hard to see, but clearly this guy right here, this x value of -1 is a 0. In other words, we can say that f of -1 is equal to 0. And if I look to the left here, where the x values are less than -1, you see that you're not going to have another 0 there. So in other words, this by definition is a lower bound than -1 because there are no real zeros that are less than -1. Now, if we come back up here and we do the test, you're going to see that it fails. So let me go through this real quick, and then I'll talk about what's going on here. So let me just take this as a 4, this as a -16, this as a -8, this as a 16, this as a 4. You do not have a constant here, so put in a 0 for that. And let's put this like this, and then put a -1. I'm just going to drop this down and then go through. So -1 times 4 is -4. -16 plus -4 is -20. -1 times -20 is 20. -8 plus 20 is going to be 12. -1 times 12 is -12. 16 plus -12 is 4. -1 times 4 is -4. 4 plus -4 is 0. And then -1 times 0 is 0. 0 plus 0 is 0. So when we look at this, again, let's say we're doing the rational roots test or something like that. And basically we would find that this guy's a 0. But we would not determine that this guy is a lower bound. Why? If you look at the test, again, it's supposed to alternate in sign. So this should be positive, negative, positive, but then this should be negative. So this right here is going to cause it to fail. But again, if we go back to this graph right here, clearly -1 is a lower bound. So what is going on? Well, this is what we call a one-sided test. What it means is that if I test something, so let's say I test -2, which I'll do in a moment for you, and it works as a lower bound, in other words, it passes the test, I can conclusively say that it's a lower bound, and you will not have a real 0 that is less than that number. If I do the test with something and it fails, it really doesn't tell me anything. It's inconclusive. You cannot say that -1 is not a lower bound because it failed the test. That's what we mean by a one-sided test. If I was to erase this, and let's say I did -2, I already know that's going to work. So let's plug in -2 right there, and you drop this down. So -2 times 4 is -8. -16 plus -8, that's going to be -24. And then -2 times -24, that's positive 48. -8 plus 48, that's going to be 40. -2 times 40, that's -80. 16 plus -80, that's -64. And then -2 times -64, that's positive 128. 4 plus 128, that's 132. And then -2 times 132, that's -264. 0 plus -264 is -264. So using the bottom row here, you have positive, negative, positive, negative, positive, negative. So this does pass the test for a lower bound. So we can conclusively say that -2 is a lower bound. In other words, there are no real zeros that are less than -2. Again, if you go back here, there's -2 for the x value. You can clearly see that that does work. There are no real zeros that are less than -2. But again, when we did -1, it did not pass the test. So that's something that you really need to keep in mind when you're working on these problems. If something does not pass the test, you cannot say conclusively that it's not a lower bound or upper bound just depending on what test you're doing. You can only conclusively say that it is an upper bound or lower bound if it does pass the test that you're doing. So hopefully that makes sense, and maybe that'll save you some frustration if you're working on a problem like this in a textbook, although most of the textbooks will just give you problems where they say, show that this is an upper bound or show that this is a lower bound, but some of them do use problems like that, so it's really based on which book you have. So here I'm just going to answer that the tests, let's just put the test, maybe I'll put the here, so the test is inconclusive. Inconclusive. Meaning we cannot determine that this guy right here, this -1, is a lower bound, even though it is. All right, let's take a look at problem 6. So here we have f of x equals 2x to the 4th power minus 2x cubed minus 5x squared minus 3x plus 2. We have a k value that's 3. Again, if this is positive, you're going to check for an upper bound. Let's go ahead and say we have 3 there, and let's set this up. So we have a 2, we have a -2, a -5, a -3, and then a 2. Let me just redo that, and let me do this like this and drop this down. And so let's go ahead and get started. So we know that 3 times 2 would give me 6, and then -2 plus 6 is 4. 3 times 4 would be 12. -5 plus 12 is 7. 3 times 7 is 21. -3 plus 21, that's going to be 18. 3 times 18, that's going to be 54. 2 plus 54 is 56. So again, everything here is positive. As long as it's non-negative, you can have zeros here. So as long as it's non-negative, you're okay. You can conclude that your k value, which is 3 here, is an upper bound. So you will not have a real 0 that's greater than 3. So let's say that this is an upper bound. All right, for problem 7, we have f of x equals x to the 4th power plus 7x cubed minus 25x squared plus 11x plus 6. We have a k here that's equal to 1. So let's put a 1 here, a 7 here, a -25 here, an 11 here, and then a 6 here. And then let's put a 1 here. So this is positive. So we're going to test for an upper bound. Let me drop this like this. So 1 times 1 is 1, 7 plus 1 is 8, 1 times 8 is 8. Negative 25 plus 8, that's negative 17. And then 1 times negative 17 is negative 17. 11 plus negative 17, that's going to be negative 6. 1 times negative 6 is negative 6. 6 plus negative 6 is 0. We're testing for an upper bound here, so you cannot have a negative entry in the bottom row if something's going to be an upper bound. It has to be 0 or positive only. So this one right here is going to cause it to fail. This one also, but again, if you're in this section and you're not actually trying to find zeros, you're just trying to do the test. Once you get a negative entry there, you can just stop and say that the test is going to be inconclusive. Remember, it's a one-sided test, just like we talked about in problem 5. So you cannot conclude that your k here, which is equal to 1, is not an upper bound. It's inconclusive. I'll just tell you that I've looked at the zeros for this, and it actually is not an upper bound, but again, you can't conclude that from the test. So let's just put that the test is inconclusive. All right, for problem 8, we have f of x equals 4x to the 5th power minus 11x to the 4th power minus 18x cubed minus 7x squared minus 4x. The k value here is negative 4. So again, if this is negative, you're testing for a lower bound. So let's take 4, negative 11, negative 18, negative 7, negative 4. And again, you're missing your constant, so just put in a 0 for that. Let me redo this. So let me drop this down. And we're going to multiply. So negative 4 times 4, that is negative 16. Negative 11 plus negative 16, that is negative 27. Then negative 4 times negative 27, that's 108. Then negative 18 plus 108, that's going to be 90. Negative 4 times 90, that's going to be negative 360. Then negative 7 plus negative 360, that's negative 367. Negative 4 times negative 367, that's going to be 1,468. Then negative 4 plus 1,468 would be 1,464. And then negative 4 times 1,464, that's going to be negative 5,856. Let me fix that 5 there. Let me extend this a little bit. So 0 plus this negative 5,856 would be negative 5,856. Again, we don't care about any of these entries. We're just trying to figure out, does it alternate? So this is positive, negative, positive, negative, positive, negative. Yes, it does. So this guy right here is going to be a lower bound. So let's go ahead and say that we have a lower bound. Again, that just means that you will not have a real 0 that's less than this negative 4. All right, for problem 9, we have f of x equals 3x to the 4th power minus 14x cubed plus 11x squared minus 14x plus 8, where k here is equal to 1. So let's take the 3, the negative 14, the 11, the negative 14, and then the 8. And then let's put the 1 right there. Let's drop this down. We're going to be testing for an upper bound because this is positive here. So we have 1 times 3, which is 3. Negative 14 plus 3 is negative 11. 1 times negative 11 is negative 11. 11 plus negative 11 is 0. 1 times 0 is 0. Negative 14 plus 0 is negative 14. 1 times negative 14 is negative 14. 8 plus negative 14 is negative 6. So again, if you're testing for an upper bound, you cannot have a negative entry. So right away, when you get this negative 11, you can just stop if you're in this section. Again, if you're looking for zeros, and that's why you're doing the synthetic division, then you'll just continue to the end. You'll see this is not a 0 because the remainder is not 0. But in this particular case, if you're in this section, you can just stop here. Now again, this is a one-sided test. So we cannot conclude that this 1 is not an upper bound. We don't know. The test is inconclusive. So we'll just say the test is inconclusive. And I'll just tell you, I looked at the zeros already for this. And so this actually is not going to be an upper bound. So you do have a real 0 that's greater than 1. But again, you cannot figure that out from this test. It's going to be inconclusive. All right, for problem 10, we have f of x equals 3x to the 4th power minus x cubed minus 2x squared plus 3x plus 2. The k value here is equal to negative 4. So let's put a negative 4 here. And then let's take the 3, the negative 1, the negative 2, the 3, and then the 2. Let me fix that. So we're going to be testing for a lower bound, again, because this is negative. Let's drop this down. Negative 4 times 3 is negative 12. Negative 1 plus negative 12 is negative 13. Negative 4 times negative 13, that's positive 52. Negative 2 plus 52 is going to be 50. Negative 4 times 50 is negative 200. 3 plus negative 200 is going to be negative 197. And then negative 4 times negative 197, that's going to be 788. And then 2 plus 788 is 790. So the question is, does this alternate? This is positive, negative, positive, negative, positive. Yes, it does. So this is going to be a lower bound. you will not have a real 0 that's less than -4. So I'm just going to write that this is a lower, let me fix that. So a lower bound.